Okay, I want to go over the second page on 2.5b, 2.4b. Okay, so the first set of problems, the drug company is hoping that their new blood pressure medicine works at least as well as a competitor's drug test that has a 75% success rate. Is this a one-tail or a two-tail test? One-tailed, how come? It's at least as good. Okay, so this company wants to be better than 75%, but what would the null hypothesis be? The H naught would be pi is equal to 7.75. What is the alternative? Greater than 0.75. If the company tests the drug on 125 people and has a success rate of 77%, is that evidence that the new drug works better than the competitor's drug? What did you get for your p-value? So you're going to run a simulation. What was your p-value? Oh, do you need me to do it? Okay. Let's pull this up. Rossmann 1 proportion. So we're going to run a 0.75 test. What is my sample size? 125. And we'll just run 1,000 samples. And then what is our proportion of success in our sample? 77%. So I'm going to type 0.77. And I get a p-value of about 27. When my p-value is 27, I'm going to accept the null. And do I think that there is a significant difference? No. Oh, I was at lunch the other day. Look at this. Why do I have heavy whipping cream in my fridge? Don't ask stupid questions. But look down at the bottom. There's a note, and it says, well, sorry, on the front it says, our farmers pledge not to use artificial growth hormones. Okay? And then there's an asterisk underneath the nutrition facts, and it says, no significant difference has been shown in milk from cows treated with artificial growth hormones and non-treated cows. So the front, one of their selling points, right there on the front of the box, our farmers pledge not to use artificial growth hormones. Okay. However, they don't want to get sued by people saying, well, there's no difference. So on the back, they have this little caveat, and it says, no significant difference has been shown in milk from cows treated with hormones and non-treated cows without hormones. So the reason I'm showing you that is they use the word significant. So what does that mean? They said statistically, well, first, we will not buy milk from farmers that use growth hormones. However, no difference has ever been found between hormone cows and non-hormone cows with regard to, well, it just says no difference. It doesn't even say what it was. So their advertising point is, hey, we don't use growth hormones. We don't buy milk from farmers who use growth hormones. And then on the back, they're saying, but just so you guys don't sue us, no statistician has ever found any difference between hormone cows and non-hormone cows. Except the non-hormone cows are bigger. Anyway, I thought that was interesting. All right. So if this were a two-tailed test instead of a one-tailed test, would that change the results? No. Would it? Is it easier or harder to reject the null on a two-tailed test? It's harder on a two-tailed test because you find your p-value and then you double it, right? So a two-tailed test is harder to reject the null than a one-tailed test. Okay. You are in charge of determining if a particular dice is fair. You decide to test this by rolling the dice 150 times and counting the number 3. Is this one-tailed test or two-tailed test? 2. How come? Right. We are testing fairness, which would equal 1 in 6. And if the dice is above 1 in 6, that would be unfair. And if the dice is below 1 in 6, that would also be unfair. So this is a two-tailed test. What would the null hypothesis be? Pi is 1 in 6, which is like 16.67%, or just the fraction 1 over 6. What is the alternative? Not equal to 1 over 6. If you roll the dice 150 times and 3 shows up 22.5% of the time, is this evidence that the dice is fair? Now, why did I suggest 10,000 simulations instead of 1,000? 1 in 6 is not very likely, right? The less likely you are to, well, it's actually, the farther your pi value is from 50%, the more the more simulations it's going to take to build a normal curve. So here, I'm going to do 0.1667, and my sample size was 150. And I'm going to do, well, so watch this. Oh, that actually isn't too bad of a normal curve. But now I've got a nice curve. And what is my p hat? 22.5. And I can either take my 0.385 and double it, or I could click the two-sided and it doubles it for me, and I get 6.55%, which means I accept the null. Okay. If this were a one-tailed test instead of a two-tailed test, would that change my results? Yes, it would. So if I go back to the app and I go back to one-sided, now my p-value is less than 5 and I would reject the null. But we had no reason to believe that the dice was going to come in greater than 16%. We were testing, is it 1 out of 6, or is it something different? And so in this case, we're going to accept the null because we have to count both sides because it's a two-tailed test. All right. A brand new player on a softball team claims her batting average is 325, meaning she gets a hit in 32.5% of her at-bats, minus the walks. The coach plans on testing this against that player's, I missed an apostrophe, next 12 at-bats. Is this a one-tailed or a two-tailed test? Two-tailed. Okay. What is the null? Pi equals 0.325. And the alternative? Not equal to 0.325. In her first 12 at-bats, the player gets 7 hits. Is that evidence that her original statement was wrong? Let's run this. So our probability of success is assumed to be 0.325. And we are measuring this against 12 at-bats. Okay. And she ends up getting, well, I'll just do number. She gets 7 hits, which is, no, that's not right. Oh, 3, I wanted 7. Okay. Which is about 58% of the time. And I need a two-tailed test. Am I going to accept or reject the null? I'm going to accept the null. Now, isn't that crazy? She did nearly twice as good as she claimed to, and that still was not enough to suggest that her original statement was wrong. Why did we have trouble rejecting the null in this case? So she claimed 325, and she actually hit 583? So she nearly doubled the batting average that she claimed, and yet we still don't have enough evidence to reject the null. Why is that? The sample size, 12 at-bats it's hard to disprove somebody when you only take 12 samples. Okay. A grocery store owner wants to know how much of each type of ice cream to stock in order to maximize sales. Right now, 1/3 of the ice cream in the store is vanilla and the rest is other flavors. He plans to conduct a survey to determine if his current percentage of vanilla is correct. Is this a one-tailed or a two-tailed test? Does he have any reason to think that his value is too low? How about too high? Nope, so this is a two-tailed test. So the null hypothesis is going to be pi equals 0.33, and the alternative is pi is not equal to 0.33. If the grocer interviews 550 shoppers and 209 of them say vanilla is their favorite, is that evidence against the null? So we are assuming a value of 0.33, and 550 shoppers are asked, and what was the 209? So if 209 of them like vanilla, 209, okay, so that's 38%. Is that 38% far enough away from 33% to reject the null? Yeah, it is. If we add the right side and the left side, I get about 2% as my p-value, so we reject the null. Would that change if we did a one-tailed test instead of a two-tailed test? No. We would go from 2.2% down to 1.1%, and we'd still reject the null. Okay, that one's done.